Far beyond Neptune, something is moving in a way it shouldn't. Astronomers found an object so distant and with an orbit so strange that none of the known planets can explain it. Something pushed it there. A passing star, a hidden planet, or something we haven't discovered yet. And the first clue to that mystery is a frozen world called Sedna.
Out there, far beyond the last planet you were ever taught in school, something is moving. Not fast, not bright, not dramatic, but wrong. In the cold outskirts of our solar system, where time stretches, where sunlight barely survives the journey, there is an object following a path that defies everything we thought we understood about gravity. Astronomers didn't notice it at first. It was too faint, too slow, too distant. But once they did, they couldn't ignore it. This object doesn't orbit like the rest. It doesn't listen to Neptune. It doesn't belong to the neat, flat plane of the solar system. Instead, it vanishes into darkness, then returns thousands of years later, as if pulled by something we cannot see. It moves in a way that shouldn't be possible, far beyond Neptune, in the icy darkness where sunlight is barely a whisper. Astronomers have found an object with an orbit so strange, so extreme, that it's forcing scientists to rethink the architecture of our solar system. It doesn't behave like the others, and that's exactly why it matters. The outer solar system is not empty. Beyond the orbit of Neptune lies the Kuiper Belt, a vast region filled with icy bodies, dwarf planets, and ancient debris left over from the formation of the Sun. Objects like Pluto and Eris orbit here in relatively predictable paths. But every so often, astronomers find something that doesn't follow the rules. One of the most bizarre discoveries in this region is Sedna, a world nearly 1,000 kilometers across with an orbit unlike anything else known when it was discovered. Sedna doesn't just orbit far from the Sun. It disappears into deep space. At its closest approach, it comes no nearer than about 76 astronomical units from the Sun, more than twice Neptune's distance. At its farthest point, it travels nearly 1,000 astronomical units away. For comparison, Earth is 1 astronomical unit from the Sun. Sedna's orbit takes over 11,000 years to complete. And here's the strange part. Its orbit is so distant and so detached that Neptune's gravity cannot explain it. Normally, objects in the Kuiper Belt are influenced by Neptune's gravitational pull. That interaction shapes their orbits over time. But Sedna is too far away. It's dynamically isolated, which raises a simple but unsettling question. What put it there? When Sedna was first discovered, astronomers were stunned. Its elongated orbit suggested that something massive must have disturbed it long ago. But what? One hypothesis suggests that during the Sun's early history, when it was still part of a dense stellar cluster, another star may have passed relatively close. That flyby could have gravitationally nudged icy objects outward, trapping them in elongated orbits like Sedna's. Another idea is even more dramatic. Perhaps there is a massive, undiscovered planet far beyond Neptune, something often referred to as Planet 9. This hypothetical world, if it exists, could gravitationally shepherd distant objects into unusual orbits. Evidence for Planet 9 remains indirect, based on clustering patterns of extreme trans-Neptunian objects. No direct observation has confirmed it yet, but Sedna helped spark that entire debate. And it's not alone anymore. Astronomers have since found other extreme trans-Neptunian objects with similarly elongated and oddly aligned orbits. These objects reside in what is sometimes called the inner Oort cloud, a transitional region between the Kuiper Belt and the distant spherical Oort cloud of comets. Their orbits are too detached to be easily explained by the known planets, which means either our solar system experienced dramatic events in its infancy, or something massive still lurks unseen. The discovery of these distant objects relies on powerful telescopes scanning faint, slow-moving points of light. Observatories funded in part by NASA and international collaborations use long exposures to detect motion against background stars. These objects are incredibly faint. They reflect almost no sunlight. Tracking them requires patience and years of follow-up observations to calculate accurate orbits. And the more we look, the stranger things get. Some objects beyond Neptune have highly inclined orbits, tilted steeply relative to the plane of the solar system. Others have perihelia, closest approach distances, so far from Neptune that traditional gravitational interactions cannot account for them. It's like finding footprints in the snow without seeing who left them. If a passing star sculpted these orbits billions of years ago, that would tell us something profound about the Sun's birth environment. It would suggest that stellar flybys were close and common in the early cluster. If Planet 9 exists, that would revolutionize planetary science. Imagine discovering a planet several times the mass of Earth orbiting hundreds of astronomical units away. It would instantly become one of the most significant discoveries in modern astronomy. But there's also a more subtle possibility. Some researchers argue that observational bias might exaggerate the clustering patterns. Perhaps we're only detecting certain orbits because of where and how we look. Ongoing surveys aim to resolve that question by scanning broader swaths of the sky. Regardless of the explanation, Sedna remains one of the most isolated and enigmatic objects known in our solar system. Its surface is thought to be reddish, likely coated with complex organic molecules altered by cosmic radiation. Temperatures on Sedna never rise much above -200 degrees Celsius. It spends most of its 11,000-year journey in near total darkness. From Sedna's perspective, the Sun would appear as just another bright star. That alone is surreal. And yet, Sedna is gravitationally bound to our Sun. It is part of our system, even if it barely interacts with it. The existence of such objects reminds us that the solar system does not end at Neptune. It extends far beyond, into regions we have barely mapped. The outer frontier is not empty. It's just difficult to see. Future observatories, including wide-field survey telescopes, are expected to discover many more distant objects. Each one will refine our understanding of the solar system's boundary and its formation history. If we find dozens of Sedna-like worlds with similar orbital alignments, the Planet 9 hypothesis strengthens. If their orbits appear random and scattered, stellar flybys become more likely. Either way, the strangeness beyond Neptune is real. There are worlds out there moving in deep, frozen arcs that take thousands of years to complete. Worlds shaped by forces we are still piecing together. And Sedna, the first of its kind, remains a symbol of how incomplete our solar system map still is. For centuries, humanity thought the solar system ended at Saturn. Then Uranus was found. Then Neptune. Then Pluto. Each time we believed we had reached the edge moved. Now, beyond Neptune, in the dim twilight of interstellar space, objects like Sedna are quietly tracing orbits that hint at hidden history, perhaps even hidden planets. The strangest object ever seen beyond Neptune isn't strange because it glows or explodes. It's strange because it shouldn't be where it is. And until we understand why it's there, the outer solar system remains a mystery waiting to unfold.
Thanks for watching. If you enjoyed this journey through the cosmos, hit like, subscribe, and tap the bell. And when you're ready for your next space mystery, click the video right here.